So I've fitted a new pulley, giving me more options for speed. The largest pulley is, no, larger, 5 inches, 4 inches. I've not measured it, but the speed I can get out of it with the largest pulley on the motor and the smallest on the spindle is 13,500. I don't think I want to go faster than that. This is the lowest, so that's the smallest spindle on the motor and the largest spindle, the largest pulley on the spindle. And the reason for that is I'm going to try milling. I'm going to try milling a slot across the front of that. I think you can use a faster speed than that. Just a high speed steel 6mm endmill. And that's a piece of, I think it's mild steel, yeah, it's mild steel. No trouble with that. Spindle on the lathe is locked, by the way. It's just a bit of scrap steel. There is a hole already in the middle and its side here. Tiny bit of lube. Well, it had absolutely no trouble with that. It's a good finish. So I'd say that was a success. Well, as you can see by the mess, this is still a work in progress. I made a few modifications to the drilling and grinding spindle. You can see I put a larger motor pulley on that's got 4 different size pulleys. The largest one gives me higher speed obviously than the single pulley that was just sort of so big. and I did measure the speed of the spindle. At maximum it's about 13,500, but it didn't sound very happy at that speed. So I don't think I'll be pushing it that fast. I also added a thumb screw here, because with the tension of the belt it did tend to twist the motor on its mount, despite that being tightened underneath. So that just pulls it against the hinge bracket, and that holds it solid. And I've also got hold of some small grinding wheels. These were originally 70 millimeters. Had to make an arbour for it. Hello, Hagel. I've just dressed this, leaving just 1/4 inch standing proud, which will grind. The rest of it's lower than the surface, so that shouldn't do anything. That's the setup for dressing. The lathe spindle is locked. This was all covered at the time, and I've got a little diamond in there, and that is set just below centre, as you might be able to tell. That stops it grabbing. So what I'm going to try and do now is see if it grinds. I've already tested it. It mills with a 6 millimeter endmill anyway. Now's a test to see whether it'll grind. So this is the setup for grinding now. As you can see, I've covered the chuck with foil, because what I find is that I found in the past, if the chuck's running, if the spindle's running, it tends to suck stuff into the chuck, and the last thing I want is grinding dust being sucked into the chuck. So that covers that, and held in the chuck is this old D-bit counterbore type thing that I made a long time ago. It's made of hardened silver steel, so we'll see whether we can put a finish on that. Covered the lathe bed as best I can. Still need cleaning afterwards. So this is the first test. Let's see what happens. Power the lathe up. Need to run the lathe in reverse. Okay, spindle on. Then we can make some sparks. Right. And the answer to that is yes. Trying to make sure nothing catches. Engage the drive. This is not engaged. No. in reverse, so it's going backwards. Try again. It's currently doing 3,500 on the motor, which is about 8,000 to 9,000 at the wheel. Trying to keep my head out of the way, because I don't know what this wheel's going to do. There's no guard over the grind wheel, there's no guard over the belt either. I do wear safety glasses, so if the worst comes to the worst, I'll just get a facelift. I'll stand on this end, I think. These wheels seem to be fairly soft when I was dressing them. They're only cheap rubbish. The main consideration for a tool like this, the Spindle, is that it's got to be really solid, stable, no slop at all. And the way I've made this, there's 6 inches between each set of bearings, and that's enough to hold it pretty stable. I think we're doing a good job, can't really see it finished. I'll let it finish this cut and then we'll take a look. Not sure how deep this cut is, it's more than a that. Back that off. Wow, that's pretty damn good. I've just put half foul on. I'm going to see how that looks. Spindle bearings are stone cold. so they're not stressed. Can't feel any vibration at all, so everything seems to be reasonably well balanced. That's the other key factor in getting a good finish. With the wheels bouncing against the work as it does, if you've got any play whatsoever, then you're just not going to get a good finish at all. Also, it's no good trying to grind soft mild steel. It doesn't really like it much. As I say, this is harder than silver steel, and that's the kind of thing that you would try and grind. Later on I'll try grinding a lathe centre. Wow, that's perfect. Jesus. That worked better than expected, really. And I've tried with a Dremel, and I've tried with a die grinder. I actually did the chuck jaws on my grip true chuck with a die grinder, but I never got a finish like that. Just pull it out the chuck, find a hole in there somewhere. I don't know whether it comes across really quality of finish. Well, I can assure you that's pretty good. Another cheap tool I bought was this thing. Just arrived today. It's a digital angle ruler. Now it's quoted as being accurate down to 0.05 degrees. My intention is to see how accurate it is for one thing, and whether I can use it to set the top slide more accurately than the crappy markings on the cross slide itself. Sorry, on the top slide, because you can barely set it to 1 degree. Well, we put that in a chuck, like so. I can rest that against the edge of the top slide. I should be able to set angles much more accurately. So for something like a 60 degree lathe centre, that'll go in the chuck jaws will hold it, and then this edge will rest up against the side of the top slide. Anyway, I'll try that later. Just thought I'd show you. It's only a few quid, less than 10 quid. Amazing.